Welcome to today's webinar resident series, Understanding Partial Dentures, Classification, Design, and Materials. This lecture is being presented by our very own Tremaine Watkins, CDT. And with that, it is now my honor to introduce Adam Dreyfus, Director of University, Government, and Institutions.
Good morning to everybody. I hope everyone is enjoying their resident year so far, and you've got lots to look forward to as we grow together over the next year, or academic year, as I like to say. But you're not here to hear me speak. You're definitely here to hear Tremaine Watkins cover this amazing topic of partial dentures. And without further ado, Tremaine, take it away.
Hey, everybody. Thank you very much for joining us. Let's jump in. So the first thing I realized when I wanted to talk about this is that I needed some better academic sources. A lot of times in the dental lab biz, if for those of you that aren't familiar with it, we tend to have more tribal knowledge than peer-reviewed articles. So I want to I'll reference these resources quite a bit. This is very, very helpful in kind of organizing this presentation. So you might be asking yourself, why in the world are we even talking about partial dentures today? As you guys know, root form implants and very predictable hard and soft tissue grafting means that most of the time we could restore a patient successfully and long-term with a dental implant. So why would we even be doing partials? Well, as you guys know, there are a few concerns. One is that implants are usually more expensive than partials. And so there are going to be some patients that either can't or won't make the investment in dental implants. I think as clinicians, one of the challenges is learning how to present the value in a dental implant so that people understand it's more complex, it's therefore more expensive, but it also might have a better long-term prognosis, both for the individual restoration and for the surrounding tissues. And then there's going to be times where you need a provisional restoration, or you need, I think that, I guess, short version is that we're going to be doing partial dentures for the foreseeable future. So it's good to kind of understand this and know how to effectively deploy them in your practice. So Kennedy classifications are really important. In researching the article, I found out there are 65,000 possible combinations of teeth and edentulous spaces in a patient's mouth. I didn't run the math myself, but I guess the point is that if you had to figure out a separate treatment plan for all the different possible combinations it could present, it makes it pretty difficult. So Dr. Kennedy in 23, and then Dr. Applegate in 1954 made these groupings so that we could kind of talk about 4 plans instead of 65,000 plans. So you can see them here. Kennedy class 1s are going to move. This is one of the things. Because of the resilience of the tissue, even if we make a perfect prosthetic, you're going to see some movement. So when we're designing the prosthetic, we need to minimize the movement and understand how, what's a good way to put it? How to both minimize it and how to deal with it. And that we'll talk about that more later. Class 2 has movement and also a fulcrum, like from here to here. So we need to figure out how to limit that. Class 3, we should be able to make a pretty stable design on it. And, you know, we need to talk about how to do that in a way that's comfortable for the patient. And then class 4 are usually, again, fairly stable like a class 3, but they're very demanding cosmetically. So then Applegate's rules basically are like, how do you, in borderline cases, how do you decide which Kennedy class a case is in? So basically, the first 4 rules kind of talk about a posterior space only counts if we're going to restore it. Rule 5, though, is really important because if a case looks kind of, say, class 4 and kind of class 1, it's going to be class 1. And then we can talk about in those situations when we've grouped a case into a given Kennedy classification, then the spaces that really didn't classify it are called modification spaces. And then there are no modification spaces for class 4. In other words, as soon as a person starts missing posterior teeth, they're not class 4 anymore. Here are a couple examples. On the maxillary arch, on both arches, we're going to assume we have a model, all the extractions have been done. On the maxillary arch, if we choose to replace number 15, we change the case from a class 2 to a class 1 because we have bilateral posterior saddles, basically, posterior dentulous spaces. And then on the mandible, this is an interesting case because you have an anterior space like a class 4, but you also have bilateral spaces like a class 1. And what becomes important on this is that since you can't have modification spaces on a class 4 case, this becomes a class 1 with an anterior modification. And again, you're like, why do we care? More useless stuff that we're learning? No, it's so that we have to understand this partial is going to move, and we're going to need to follow the design rules for a class 1 case, not a class 4 case. So these are the components of a partial denture. And let's talk about what they are, and then we'll talk more specifically about them related to various partial designs. So the major connector obviously connects all the pieces of the partial, and it needs to be as rigid as possible most of the time. One of the things we'll talk about with flexible partials is that your major connector also flexes and what the implications are of that. Minor connectors connect the major connector to different things like the retainers and different things like that. Couple things about them. We want as few as possible for hygiene. And if we can make them do double duty, so much the better. So if a minor connector is also a guide plane, that could be awesome. The direct retainers are what actually hold the partial in place. We need enough in the right spot. Indirect retainers are basically rest. And what their goal is, like this case would have a fulcrum axis here. And so by having that indirect retainer on the cuspid, it prevents the saddle from falling down, basically, on this case. This is a maxillary case. And then the denture base. This is the point of the whole thing, is to give the person the teeth, but also denture base adaptation is really important, especially for class 1 and class 2s, where it can be used to help prevent some movement. So there's basically 2 ways to do partial dentures today. One is the historic analog way, and one is a digital way using design. Now, in talking to people who've been doing this for a long, long time, I have yet to meet anybody who's like, I wish I could go back to analog. The digital is too predictable and easy. So I think that the equipment for digital manufacture is pretty expensive right now. And so I think that that's really the limiting step for this. But I think it took the fixed side of dental a long time to move into the CAD space, but I see removables moving much more quickly. In some ways, removable labs, and then I suppose for you guys as well, are kind of bumping up against the limitations of technology. They're like, I'd like to do digital now, but some of the technologies either aren't readily available or aren't as mature as we would like. So I think during your career, you're going to see early in your career, the majority of removables being done with a digital workflow. The one thing I would say about the analog process is that most of the current digital processes are designed to emulate the way that we did things analog. So as I'm talking about this, I'm going to use analog terminology, and then I'll talk about how it actually works digitally. So on the left, you see partial design by hand back in the day, and here you see a digital partial design. This is specifically 3Shape. 3Shape and exocad, I would say, are the 2 main design software that are used. And 3Shape tends to have a gray background, and exocad tends to have a purple background. The reason I mention that is because if your laboratory sends you screenshots or whatever for interest, you can kind of tell which design software is used by which background it has. So with a partial, we're going to start out with survey. And if you think about it, a partial is like a fixed bridge that covers the whole mouth. So, if you're doing a 3-unit bridge and you're prepping it, you got to prep out all the undercuts and stuff. Of course, we can't do that with natural teeth. So we wind up having a whole bunch of undercuts we have to block out. So the survey process is designed to get rid of all the undercuts from a specific path of insertion. One of the things that's really important about partial dentures is that the path of insertion that we set isn't just going to be used one time to glue in a bridge. It's going to be used multiple times a day by the patient. So we want to make sure that in general, the plane of occlusion is fairly flat to either the screen or the surveyor so that it's an easy path of insertion for the patient. If we create an exotic path of insertion, that's a problem. The other thing is that we can kind of modify it a little bit in terms of tilting from the right to the left side to try and get our heights of contour more symmetric, which creates a more aesthetic and partial and also more even retention cross arch, which is really important. The other thing about surveying is that once we know where all the undercuts are, we know where we can put our clasps because our clasps need to engage specific undercuts. So what are our goals when we're making a partial? We want good retention, which means both that once we seat the partial, it doesn't come loose easily, but also that it is easy/possible to place. Once the partial's in place, we want it stable. Now, again, these are kind of in order because if retention isn't under control, none of the rest of this is going to happen. If the retention is good, we're more likely to have good stability as long as our retention is spread well around the arch. Support has two sides of it. One is that we want our partials to support the patient's bite and other tissues like their tongue, cheeks, that sort of thing, lips. And then the other thing is we want to make sure that our partial is well supported. And most of the time that's going to mean rest and tissue and connector adaptation. We also want to make sure that when we're calling on different teeth to support parts of our partial, that we're not overloading them based on their periodontal attachment and their ability to withstand all the load that we're putting on them. If we get all these first three really good, then comfort is mostly a finishing thing. In other words, how are the transitions to the tissue? Is the resin smooth? How have we relieved in the areas and potential pressure points like tori, the incisive papilla, the frena, the genial tubercles, stuff like that. We want to make sure that our denture bases end on stable tissue, not on mobile vestibular tissue that's going to hit those edges and create sore spots. And then aesthetics. If we don't have the other four, the partial is not going to be aesthetic, but this is probably one of the most challenging aspects of partial dentures. First is that people don't want to see clasps, but a lot of times leaving out 5 through 12 from a partial just isn't a possibility. And so we need to talk with our patients about their aesthetic demands. We need to look at undercut versus lip line and see if we can use bar clasps to kind of hide the clasp. And you want to make sure that when you're treatment planning these cases, you underpromise and overdeliver. And again, good, better, best is an option here. If your patients are like, well, I don't want to see any clasp, you can tell them, great, let's place a couple implants for you. Again, it's not, fortunately today, when I first started in dental labs back when dinosaurs ruled the earth, there were cases where we had to use a partial because osseoid-integrated implants weren't really a thing back in the 80s. And so it was like we were telling the patients, this is what you're going to have to live with. Fortunately for you guys, that's not really the case. You can say, well, if you don't want this, great, let me talk to you about some other solutions. And again, that's part of building your dental toolbox, is so that you know what those other solutions are. So what are some general rules of partial design? We want to make sure that we use the least amount of things possible. So if we have a design with 5 clasps and a design with 4 clasps, the 4 clasp design is better because it's got less areas for food to get trapped. It's just going to be simpler for hygiene, simpler for maintenance. And so we want to kind of, one of the things about partial design is there's more than one way to design a partial for a given case. And we want to kind of challenge ourselves to be as creative as possible to get a good result. We need good base adaptation, and we need to talk to the patient about, externally loaded bone is going to resorb. And so over time, the base adaptation will almost always get less and less and less. So we need to talk to the patient about relines, making new partials, that they need to understand that this is not a lifetime restoration. This is a restoration that will last for a given period of time. It'll need a certain amount of maintenance. But the better the base adaptation, the slower the rate of resorption. So if the patient chooses not to be on the reline schedule and do the maintenance that we've talked about, then they can expect to replace their partials more often. If we don't have to grind on teeth, that's awesome. So we want to kind of look at the bite and different things like that to see if we can make the partial that we need, that our patient needs, without modifications. Planning for the future, a lot of times what this means is that, unfortunately, folks who have a partial are in a situation, let's say, where they may well lose additional teeth. If we see that there are teeth that are going to be lost, we need to design our partial both in terms of materials and in terms of design so that it's not as difficult to add teeth. One of the main examples I see of this is on the mandible. Let's say that the person has 20 through 29, but 23 through 26 are pretty unstable and you're worried they're going to get lost. Sometimes designing a metal partial with a lingual plate can be awesome, because then we can just weld some lugs and add teeth as opposed to having to make a whole new partial. We want to make sure that we don't occlude on rests, just because it's hard on our partials and it can be hard on the opposing teeth as well. And then in terms of the way we apply occlusal load to a partial, except in very rare instances, we're going to want to have group function on our partial teeth. So let's start with our major connector. So we don't want our major connector on the teeth, on the areas of the tissue that are right around our teeth. So we either want to be 3 millimeters apical, like this, or we want to do a plate. We don't want to put our partial right on the free gingival margin, because we don't want to beat up that tissue if we can avoid it. Again, like we talked about, lingual plates or palatal plates can be handy if we're going to lose some anterior teeth. And then we want to minimize our palatal coverage for best taste sensation. Also understanding that, like, even a horseshoe palate or a palate like this is going to have less stability. So if a person only has anterior teeth, we'll tend to do a palatal plate and full palatal coverage. And you also want to look at what material you're using and how strong the person's bite is. You may be able to do a horseshoe in those situations, but it'll have to be somebody who can't really, really beat on the partial, who has a limited occlusal force. So our retentive grids, we want to extend over the tuberosities on the maxilla. And again, this is for clear frames and metal frames. Obviously, these rules are a little bit different, but even if we're doing a flexible, it kind of tells us where we want to end our partial. Our retentive grids should end before the retromolar pads, of course. And then tissue stops. What they are is they're little pads of metal that actually sit on the model. And they're not really, they're called tissue stops, but they're not really for the mouth. What they're for is for the model. So a lot of times with traditional processing, we're going to apply a tremendous amount of pressure in the laboratory, when we process the resin. So what we don't want is, we don't want the partial, because there's a space under this grid, and we don't want it tipping back here so that this part of the partial isn't actually well seated during the processing. Now, obviously we bury this in stone, different things like that. But we're in general, where the partial could tip during processing, we'll want a tissue stop. Now with digital, we can do what's called the snap fit partial, and we don't really need this because we can design the underside of the grid and the upper side of the grid all at one time. So it's just bonded together basically. That's a fairly new digital workflow. Guide planes. Guide planes are a little known source of additional stability. A partial that has nice guide planes doesn't need as much clasping because just the frictional fit of the guide planes can make the case much more stable. Now, two things about guide planes. We want them to be parallel to the path of insertion, and we want them to oppose each other like this. And the other thing is that these are only going to work with a really good impression, because if there's just a slight amount of variance, all of a sudden these aren't engaging and they're not really doing anything. So this is why either vinyl polyether or even better an intraoral scan is ideal for partial dentures. So we want to make sure we have enough occlusal clearance for our rest. In other words, we want to make sure that we can get enough material in there so that the rest will be strong, because the point of the rest is to absorb occlusal force. So you're putting a pretty fair amount of force on a small area. So we want 1 to 1.5 millimeters of thickness on the rest, which is either prepped into the tooth, or we can kind of fill in some of the tooth's contour based on the occlusion. And we want nice rounded internal line angles. As you guys know, sharp corners from a materials perspective are where forces tend to congregate. So you're going to have fractures tend to develop from sharp corners. So if you prep a box, then the rest is also a box. It's the negative of your prep. So if you round it, you're going to have rounded internal line angles, and it'll adapt to the stress more. We don't generally want to put rests on incisors, and we don't want to put rests on amalgams, or for that matter on any fillings, because again, we're putting all that occlusal force on there, and it's going to more likely than not damage those fillings that we've done. So a good direct retainer, what does it have? Obviously, it's going to have support, and usually that's from the rest. In other words, part of this assembly is keeping the partial from getting hammered into the tissue by occlusal force. It needs reciprocity. In other words, no matter how much undercut I put on this area here, let's say, without this arm, it's just going to displace the partial. We want it to be stable. We want it, when it's down, we want it to not move, but we also don't want it to be pulling on the tooth, so to speak. We want it to be sitting passively once it's fully to place. Encirclement's really important. Sometimes if you have a arm assembly here and an arm assembly here going the other way, you can get away with it, but we want more than 180 degrees of encirclement, so that way, even if this were the only clasp in the mouth when it was fully seated, it wouldn't be displacing the partial some other direction. And again, passivity, kind of we talked about that with stability, that we want it, once it's fully seated, we want it to just sit there. How much undercut's needed? Again, when we're doing our survey, either digitally or analog, most of the time we'll want to create 0.00 undercut. But where the tip of our clasp is, needs to be in a 3/10 for a cast metal clasp and a 5/10 for a wrought wire. And you'll need more for flexible. Sometimes you need as much as 1 millimeter, depending on how long the arm is. One thing to keep in mind is sometimes you look at clasp shapes on a partial and you're like, man, those are weird looking. Why are they that way? And the reason is it has to do with the survey line. So what we want is we want the majority of the clasp above the undercut, and then just this last third dropped into that undercut. And again, like we talked about complexity, you shouldn't need more than 4 clasps per arch. So what kind of clasps can we use? Acres are probably the most common. They're kind of a nice clasp because they have so much built in, like we talked about. They have your They have your rest, they have your reciprocating arm and your bracing arm. And this surface, your minor connector here, can also serve as a guide plane. So they can do quite a bit. The main disadvantage to them is that they have a lot of display, so they can be less aesthetic. But if you can get them in the posterior, they're definitely a great solution. And if 1 acres is good, 2 is better. You don't see these a lot, but a lot of times on class 2 cases, you'll need to get a really, really sturdy clasp opposite your edentulous space. And so the double embrasure clasp can be great. The main thing you need to look for on this clinically is you need enough space here occlusally to bring this arm through and to get your 2 rests there. But this creates a ton of retention. Basically, with one of these, you're done with that side of the mouth. You have all the retention that you need. Bar clasp. Bar clasps are nice as you get more towards the anterior because they're usually less visible, especially on the mandible if the person has a really mobile lip. Most of the time when you're designing one of these, you're not really like, oh, I really wish I had a C clasp there. It's more where the undercut is, because basically we want this whole part of the clasp needs to be passive, and then just this tip again we want to drop into the undercut. So there's a few times that we can't use these. If the vestibule's too shallow, we can't use them. And if the teeth are labioverted a lot of times, we won't be able to use them because there's so much undercut here, winds up being a huge food trap. You notice I don't have an I-bar clasp on here. The reason is because an RPI is a special kind of clasp. RPI stands for rest, plane, and I-bar. An RPI should always have a mesial rest. I've seen these with distal rests, and I guess I didn't know what I was thinking about. But if you think about these kind of clasps, these are the ones that we're going to use adjacent to a edentulous space on a class 1 and a class 2. And these are what allow the movement that makes this whole thing work. So if I put this on a distal rest on here and I put force, let's say back at the second molar, I'm basically trying to rotate this tooth this way, which is going to try to extract it eventually. So what I want instead is by putting the fulcrum point here, I allow this partial to move occlusally a little bit because of the resilience of the tissue, but yet I still can get good retention. So couple things. Not all labs know this, so make sure you mentor your laboratories about the RPIs. And then from your perspective, it's good to request I-bar clasp if at all possible, anterior to your class 1 and class 2 cases. This will again, there is going to be movement. Even if they fit perfectly, there will be slight movement. So you want to make sure that your design allows for that. So the fulcrum line is important. For a lot of these cases, like this one has a fulcrum line, but if we put double acres here and here, we can maybe eliminate that movement altogether. And then we maybe put a couple of solid rests here, maybe a guide plane. But a lot of these cases are gonna have some movement that you're seeing here just because because either there's no posterior support or because the posterior support is only on one side of the arch. So when let's say we are designing, well, let's say this case. So we need retention here and here, and we'd use I-bars, but we also would be good to put a rest. So rest right here, because when this part of the partial tries to flip up, if the retention is good here, this indirect retainer will resist that. So we want to make sure that when we're designing our cases, we're thinking about not only the forces that are pushing our partials down, but what happens when forces try to lift our partials up. So for Kennedy class 1, You'll see a lot of this is common from one to the other. We'll usually want to do a lingual bar for the mandible, a P-strap for the maxilla, again, staying 3 millimeters apical to the free gingival margin. And again, you got to kind of decide how much palatal coverage you need for patients with no posterior teeth, but just knowing that partial is going to have a lot of force on it. The denture base on this is like a base for a real denture in the sense that it should come about halfway up the retromolar paths on a mandible or over the tuberosities in the maxilla. RPI class, like we talked about, indirect retainers on the cuspids. If we have some posterior teeth and then a palatal plate to, again, resist that tipping. And implants and resilient attachments can be great for these. Keep in mind that if you're placing implants and maybe putting a resilient attachment on there, you can place the implants apical enough so that you're creating the appropriate restorative space for a implant supported restoration at some point. So make sure you talk to your patients about that. And again, a little bit of good planning can create more opportunities for your patients later on. Class 2, a lot of this is similar, but we want to make sure that we have that, we're going to have a fulcrum on these cases, and we want to make sure that we have indirect retention, oftentimes on a cuspid, on a nice sturdy tooth that'll present that tipping force. For a Kennedy class 3, oftentimes these are cases that we could restore with a bridge if we wanted to. But if the person doesn't want that, a lot of times something like this, either metal and plastic or flexible, can be a very good solution, where you basically have an Akers type design facing opposite each other with guide planes and then a tooth or two. So these can be so nice for your patients, a unilateral partial, because they're so much smaller. Otherwise, we're replacing 2 teeth and we're making a prosthetic that encompasses their whole mouth. So class 4, this is kind of what I was talking about before. You could do, technically, if we only want to do 4 class, we wouldn't do double Akers here. We just do an Akers and then another Akers clasp here. Or you could do an I-bar, but a lot of times with this, your I-bar would be coming from the mesial, so it might be not as aesthetic. So again, the retention that you're trying to push towards the back of the mouth on these cases will wind up providing a lot of the stability. Really, this clasping is more to prevent lifting in this area. And these can be very, very stable for the patient, just like the class 3s. So one of the big issues with materials is whether a partial is going to be tooth-borne or tissue-borne. So a lot of the designs we're going to talk about wind up being tissue-borne. And the challenge with these, as you know, is that we're pushing on the bone through the tissue, and over time, we're going to tend to get hard and soft tissue resorption. So we need to talk to our patients about that, and we just need to be aware of it. If we look at a case and we're like, I need tooth support on this, it's going to limit the restorative, the prosthetic options that you have. And we'll talk about that as we go along. So chrome cobalt metal frame RPD. So these things were invented in about 1929. And you're like, well, why am I still doing things that are 100 years old? And some people kind of have a concern about the chrome cobalt alloy, especially with some EU regulations from a few years ago about not using this. But there was a meta study I found done in 2022. They looked at 21 in vitro and in vivo studies that went from 95 to 2022. What they found was that this material is very close. It's not quite as biocompatible as titanium, but it's pretty close and much more than nickel. and there was no cytotoxicity to human cells during in vitro testing. So in other words, I mean, if you have patients who don't like metal, then obviously you can't do this. But just from a clinical / scientific perspective, this is still a viable option today. And there's a reason that we use it. This material is very, very strong, which means we can make it thin. It's ductile, so we can create the clasps and the rigid major connector out of the same thing. And the last thing is that all of this can be repaired. We can weld new metal onto this. We can replace the acrylic. So a person can get more life out of these restorations than perhaps some other ones. So it may not be as cool as some of the newer materials, but it really meets a lot of the demands. And I think there's some, you're going to find there's a lot of places where this might be the best solution for your patient. Also, of course, you can do rests. So this can be a tooth-borne case. Now, let's say that you take the metal frame out of it and you make a little partial. That's when you get an all acrylic partial. Sometimes we call them treatment partials, flippers. They're usually the most economic that you can get, but they're usually not intended for long-term use for a couple reasons. One is that they're not as sturdy as some of the other ones, and they're more inclined to break. The second thing is that just due to the nature of the way these are made, it's hard to get all that precise, like guide planes and different things like that. So they tend to have more movement, and with the associated, rubbing on the tissues, rubbing on the teeth, that sort of thing. So these are really something that you're going to want to use more while you're making the final partial, while a person's healing from an implant placement, something like that. We talked about there's a fairly new digital process for this called the snap fit. These can be done digitally. I think we're still seeing a lot of this done analog. It's kind of in transition right now. Flexible partials. So by today, these are still an older standards. Valplast was the first out, and it really was built on some nylon technology that was developed during World War II, believe it or not. These are very sturdy because they're difficult to tear. But when you make these partials, couple things. One is that you can't make rests, so these are going to be tissue supported. And the second is the whole partial is made out of one thing. So the major connector is also flexible. So in this particular case, if the patient bites on it, the saddles are going to depress and it's going to move a little bit. They tend to be very, very comfortable and people like them, but the teeth are only retained by mechanical retention. So on some of these other cases, the teeth are attached by monomer, so to speak. There's a chemical bond between the teeth, but with these, not so much. So having enough space on the saddles is really important because we have to have enough space for the encirclement that mechanical retention requires. And Valplast cannot be effectively repaired. I mean, people stick, because it's nylon, nothing sticks to it. So the Duraflex, which is a newer material based out of polypropylene rather than nylon, it's a little easier to adjust for you. It gums up your burrs less, and it can be repaired. What I would say is when you're working with your laboratory, kind of talk to them, because just like each of you have materials that work better or worse than your hands, dental laboratories kind of have the same thing. So you'll want to work with your lab and decide, what your lab is going to be able to get you the best result with. So you're like, well, metal frames are sturdy and they can have rest, and flexible partials are prettier and more comfortable for patients. What if we were to put them together? And you can 100% do that. You can make your frame out of the chrome cobalt material with all your rests and then process with the flexible resin. And this can be a great solution. One drawback to this is that you can't really try the clasps until the case is processed. So there's not really a try-in step where you can try in the clasp as you can with other materials. And again, the pink part of this can't be repaired. So all the caveats with the previous material apply, but these can be a really nice solution. I think sometimes people are not aware of this and don't take advantage of this. I mean, this would be great. You can see on this case, the person we're putting clasp on cuspids, and these pretty translucent pink clasps are going to look better than a metal clasp by and large. There's been a few different digital materials that have kind of come and gone, I feel like, in the partial arena, but this is one that I think I've seen it used quite a bit. So what it's called, it's from a company called Meyerson's, and their product's called VisiClear. Some labs call it ClearFrame, but this is a resin material that lets you actually do rests. So you can design it like a thick, what am I trying to say? Like a thick metal partial. So, and it is truly clear. As a matter of fact, if the rests are kind of thick, it's so clear it looks kind of bluish because of the darkness of the mouth shining through. Now with these, this frame is a variant of nylon, so it cannot be repaired, but usually it's processed with a plastic saddle so the saddles can. So I've seen some advanced polymers, not in the last couple of years. I really haven't seen much with them, but when I was working with labs that did more of them, we found that the shades were kind of weird, and it was hard to get the really nice retention that we needed. So again, talk to your laboratory about what's available, but if you've never seen this before, this can both be a cool product for a whole partial, and it can also be nice just to add a clear clasp in an aesthetic area. So if you're doing a partial with an analog workflow, how would you do it? So you'll start out with your master, opposing, and bite. You need to take, for your partials, it needs to be of the quality that you would do for a crown for the whole mouth. So partial impressions are very, very demanding. The better impression you get, the better result you're going to get. So take your time, use premium materials, use a good fitting tray, do everything you know to do to get that really nice impression, because it'll just pay dividends for you. If you have like a class 1 or class 2 with a big saddle, a lot of times those are going to be difficult to articulate. So your laboratory may need to do a bite appointment for you. If you're doing some of the flexibles or things that don't have a frame, you'd be going to delivery at the 3rd appointment. If you do, sometimes with a frame, like a metal frame or a clear frame, you'll get the frame with some teeth set on it. And so in those situations, you do a try-in. Also for anterior cases, it would be helpful, I think, to do a try-in, even for a flexible, just so that the patient can see what everything's going to look like. Your iOS has some advantages. Firstly is the intrinsic advantage of an iOS over a physical impression is that if an iOS captures, it's good. The software has decided that it was able to accurately stitch, and you've gotten into the sub 100 micron accuracy that is pretty much across the board today. As you know, a beautiful looking impression can still be dimensionally inaccurate due to polymerization problems, thickness in some areas, different things like that. So you can look at an impression and think, oh, this is the best impression I've ever taken, and it could actually not fit properly. That usually doesn't happen with an iOS. iOS does also allow you to capture bites, even if the person only has 2 teeth touching. If you can get their jaw in the right position and capture it, the space is accurate. So a lot of times you can do a 2 appointment with your iOS. I would still say that if there are aesthetic implications of the case, you may want to do a try-in just to make sure, just to give your patient an opportunity to vote before the teeth are kind of fixed and difficult to adjust. One of the things I find is that in the laboratory, removable departments are moving more slowly towards digital than than fixed departments are. So sometimes they're kind of still stuck in the for appointment mentality, and you can kind of coach your lab along and say, hey, do we really need that appointment? I believe in my iOS scans that I know I can get a good fit, and kind of have those conversations. I have a little page here at the end that shows some of the CDT codes for partials. If you'd like to get that, reach out to Adam or Jessica, and I'll send it over. So that's it. That's all I have today. Thank you very much for joining in. I really appreciate your time, and I hope you have a good day.